In this video, we're going to look at Venn diagrams. A Venn diagram can be a very useful way to represent information. I'm going to start off by showing you a couple of examples of quite straightforward Venn diagram questions, and then I'm going to show you a lot of the important notation that you'd use in more complicated questions, particularly whenever you're dealing with probability. Okay, so we've got the symbol. This symbol is a letter in the Greek alphabet, it's xi, and it represents a universal set. It means all the data that you're interested in the question. And these curly brackets, they're sets. If you go to Corporate Maths, you can watch the videos on that. Okay, so here we've got xi. It says the set of information that we're interested in is the numbers 1 to 16. And then we've got this a is equal to the multiples of 3. So a is defined as the multiples of 3. B is defined as the multiples of 4, and we've been asked to complete the Venn diagram. So this is a Venn diagram. You've got a circle that represents A, you've got a circle that represents B, they overlap in case there's anything that satisfies both A and B, and then you've got a rectangle around the outside. That rectangle around the outside is very important, don't forget that, okay? Because it means that if anything's not in A and B, it can go in that box to represent that it's not in A or B. Okay, so this is complete the Venn diagram. So A is the multiples of 3. So let's write down what the multiples of 3 are between 1 and 16. So that would be 3, 6, 9, 12, 15. And the multiples of 4 would be 4, 8, 12, and 16. And what we're going to do is we're going to put these into the Venn diagram. So let's first of all start off with the middle of the Venn diagram. So this section here would be anything that's in A and in B. So it would be a number that's a multiple of 3 and a multiple of 4. Now if you look at both of this, 12 clearly satisfies that. So we're going to put 12 in the middle because 12 is a multiple of 3 and it's a multiple of 4. So it's in A and B. This section here would be anything that's just in A but not in B, okay? So anything else is a multiple of 3. So let's put our 3, our 6, our 9 and our 15 in there. Okay, this section here, that would be anything that's a multiple of 4 but it's not a multiple of 3. Okay, so that would be the rest of the multiples of 4. So that would be 4, 8 and 16. And around the outside, that would be any other number that we haven't got in the diagram so far. So anything that's not a multiple of 3 or a multiple of 4. So let's put in our 1, 2, we've got 3, 4, then it'll be 5, we've got 6, 7, we've got 8, we've got 9, 10, 11, we've got 12, 13, 14, we've got 15 and 16. That's it. But whenever you're doing a Venn diagram question, I always recommend you check you've got all the numbers or all the data. So we've got the numbers 1 to 16, so we've got 16 numbers. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've got 16 numbers in there. So that's it, we've completed the question. So that's a Venn diagram, okay? It's quite a straightforward Venn diagram question. We've put in the numbers in A, the numbers in B, the middle section where they overlap, so anything that's in A and B, and anything on the outside is anything that's not A or B. Okay, let's have a look at another question. The Venn diagram shows information about the drinks that some students like. Okay, so some students were surveyed and this is the type of drinks they like. The first question says, how many students do not like tea or coffee? Okay, so if you can see here, the first circle here is anyone that likes tea. So these 13 people and these 8 people all like tea. The 8, well, it's both tea and coffee. So these 8 people like tea and coffee because obviously they're in both circles. These 7 here, they just like coffee, but they don't like tea. And the 2 people outside, well, they don't like tea or coffee. So the first question says, how many students do not like tea or coffee? Well, it's going to be these 2 students here. So that's going to be 2. The next question says, how many students like tea and coffee? So because it's and, it means they like tea and coffee. It's going to be the people in the middle that like tea and coffee. So there's 8 students that like tea and coffee. Next question. How many students like tea? Well, obviously we've got these 2 numbers here. We've got our 13 and our 8, and they're both in the circle for tea. So if we add them together, we'll see how many people like tea altogether. Well, 13 plus 8 is 21. And that's it. So that's how many people like tea. We've got the 13 people that like just tea, and we've got the 8 people that like tea and coffee. So altogether, there's 21 people that like tea. The next question says, how many people like coffee? So if we look at the coffee circle, we've got the 8 and the 7 inside. If we add them together, there's 15 people that like coffee altogether. The next question says, how many students are in the class? Well, if we add all the numbers together in the Venn diagram, we'll see how many people are in the class. So we've got 13 plus 8, which is 21, plus 7, which is equal to 28, plus 2, which is equal to 30. So there's 30 people in the class. Next, how many students like tea but they do not like coffee? Okay, so the people that like tea and not coffee would be these 13 people here, because they're in the tea circle but they're not in the coffee circle. Okay, so it'd be 13. And the next question is, how many students like coffee but not tea? Well, if you look at the coffee circle, that'd be the 7. 7 people like coffee but not tea. So we're sort of getting used to sort of reading Venn diagrams and understanding how to approach understanding what the numbers mean. Okay, so next example says, in a class of 24 students, 12 played the piano, 13 students played the guitar, and 4 students play neither instrument. So what we're going to do is we're going to fill in the Venn diagram to begin with, and then we're going to be able to answer the question, how many students play the guitar only. Okay, so first of all, let's put the 4 students that play neither instrument outside. Now this 12 that play the piano, that's the whole circle, okay? And 13 that play the guitar, that's the whole circle here, okay? Now we don't know which number's in the middle, so we can't just quickly fill out these 3 numbers, but what we can actually, from the information we've been given, because we know there's 24 students altogether, we can use one of the numbers. So let's just look at the 12, and we know that in the piano circle, this whole circle here, we know that there's going to be 12 students. So let's just put a 12 in there for now, okay? And we also know the 4 play neither instrument. So we know there's 12 there and there's 4 there. Now that's 16. Now altogether there's 24 students. Now there's only ever going to be 4 numbers to add together in this question. We've got these 2 here, this one and this one, but they're 12 altogether. The one that we don't know, and the 4. So if we do 12 plus 4, that's 16. Well, if we add on 8, we're going to get the 24. So that means that this section here, the bit that's only guitar, is 8. Actually, that answers our question, 8. Let's just fill in the rest of the Venn diagram anyway. Okay, so let's rub out the 12 now, and let's work out the 2 other numbers in the Venn diagram. Okay, the bit in the middle and the bit that's piano only. Now, we know that 13 play the guitar, so that's that whole circle here. Now, if there's 8 there, that means that the 5 is in the middle to make 13. So because 5 plus 8 is 13. Now we know there's 5 in the middle, and we know that 12 play the piano, that's this whole circle here is 12. If we know there's 5 there, that's going to put 7 on that side. That's it, we've filled in the Venn diagram. And just to go through the question again, it says, how many students only play the guitar? Well, that's the guitar circle, but the bit that's not in the middle, so that's it. That's it. We're now going to look at some notation that you might encounter whenever you're doing a Venn diagram question. So we've already seen A, okay, so if you have a circle here in the Venn diagram that's labelled A, anything inside it will be part of the set A. Next, inside of B is obviously B. Now, an A with a dash like this, that means the complement of A. Alright, that means not A. So it means anything that is not inside the A circle. So, well, or oval in this question. So here you've got the circle of the region for A. Anything outside of it would be A dash, which is the complement of A. Likewise, B dash would be the complement of B, so anything outside of B. Now, A and this U and then B means A union B. And that means anything that's in A or B. Alright, so anything in the A circle or the B circle would satisfy or be part of the group or the set A union B. So A union B is anything in A or B. I like to sort of consider the word or whenever I see that. And finally, A and then an N and then B. It's not like an N, it's like it's the shape, okay, the symbol. A, the symbol B, would be A intersect B. It means anything that's in A and B, okay, so anything would be in the middle region, okay. So A intersect B is anything that's A and B. Okay, let's have a look at some questions. So here's the Venn diagram. A number is chosen at random from this Venn diagram. Find the probability of each of the following. So let's see how many numbers in the Venn diagram to begin with. So we've got 1, 2, 3, 4, 5, 6, 7. So 7 numbers, and the first one says, what's the probability of getting C? Or what's the probability the number chosen is from C? So there's 1, 2, 3, 4, 5 in C, so it's going to be 5 out of 7, 5 sevenths. Probability of D, well, there's 1, 2, 3 numbers in D, so that'd be 3 sevenths. The probability of the complement of C, or the probability of C dash, means the probability of not C. So it means what's the chance of picking a number that is not in C. So we've got 5 numbers in C, but these 2 numbers, the 7 and the 2, are part of C dash, or the complement of C. So it's going to be 2 out of 7. Next, the probability of d dash. So that means that there's the probability of the complement of d, or any number that's not in the d circles. So there's 1, 2, 3, 4 that's not in the d circles. So it's going to be 4 out of 7. Next one, what's the probability of C union D? So the probability of C union D is anything that's in C or D. So there's 1, 2, 3, 4, 5, 6 numbers in the C or D circles. So there's going to be 6 sevenths. And finally, what's the probability of C intersect D? In other words, the middle region, anything that's in C and D. So there's 2 numbers there, so it's going to be 2 out of 7, 2 sevenths. Right, so our second last example, here's a Venn diagram and a number is chosen at random from the numbers in the Venn diagram. Find the probability for each of the following. So the first one, what's the probability of the complement of C intersect the complement of D? In other words, what's the probability of not C and not D? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 numbers in this Venn diagram, so it's going to be 8 in the denominator, and not C and not D, well, that's going to be the 2 numbers on the outside, so that's going to be 2/8 or 1/4. Next, what's the probability of C union not D? So that means what's the probability of C or not D? So that means that anything that's in C or not D will satisfy it. So C will be these 4 numbers, and not D, well, that's going to be these 2 and these 3. We've already got these 3 already, so it's 1, 2, 3, 4, 5, 6. It's going to be these 6 numbers, this one, this one, this one, this one, this one, this one. These 4, because it's union, it means that we're going to accept any of them. So it's going to be anything in this circle or anything outside of the D circle. So the only 2 that we're not going to be looking at will be the 10 and the 9. So it's going to be 6 over 8, and that's equal to 3/4. Right, so the last part of this question says, what's the probability of the complement of C union the complement of D? In other words, what's the probability of not C or not D? Now, because it's union, it means that it's either one of them. Okay, so if it's not C or not D, then it's part of it's accepted. So not C, well, not C, let's take it, would be that number, the 10, the 9, the 15, or the 19. Not D, well, not D would be the 15 and 19 again, but also the 1, the 2, and the 4. So the probability of not C or not D would be any of the numbers that we've ticked. So it's going to be 7 over 8. And our last question. So the last question says, a p-test has 2 sections, a theory test and a practical test. Everyone in the class who took the p-test passed at least one section. So it means that everyone's passed at least either the theory or the practical or both. It says that 70% passed the theory section. So in other words, we know there's 70% in this circle. There's going to be 70 in here. It says 81% passed the practical section. So we know there's 81 in this circle. And it says represent this information on the Venn diagram. Now, to begin with, we know that nobody failed both sections. So let's put 0 on the outside. Now, this might seem a bit difficult because we don't have very much information to find out what's in the middle, but actually we do have enough information. We know that there's 4 numbers all together in this Venn diagram that we would have. We'd have this number, this one, and the 0. Alright, now we know they must add up to 100%, so it must mean that this number plus this number plus this number would be 100. Also, we know that the 70% inside the theory section. So that means that inside this circle would be 70%. So there would be 70 in here. That must mean there would be 30 there. We could have looked at it the other way, and we could have looked at the 81 for the practical section and worked at that, and then we could have worked that out, but that's just the same thing. Okay, it says that 81% passed the practical section. Now inside this practical section, we know there's 81%. Well, if we've got 30 here, that must mean we would have 51 in the middle, because that would mean 81 in the whole circle. And finally, because we know it's going to be 100%, 30, 51's 81, leaves us 19 there. And just checking they add up together to give us the 70%. So we've completed the Venn diagram. Now, the next question is very important. It's a given, that question. It says a student is selected at random. Work out the probability that the person passed the test, work out the probability that this person passed the theory section given that they've passed the practical section. So first of all, we know that this person has passed the practical section. Okay, so we know that we're inside this circle. They've passed the practical section, so we're only really considering these 2 numbers here. Okay, it says what's the probability they've passed the theory section? So the theory section would be this 51. So it's going to be 51 out of the 81 that's inside this that's inside that circle. So the answer would be 51 out of 81, and that's it.